Very nice introduction. I am very, very thankful. So, hope I am audible and clear.
Yeah, I can hear you.
Great. So, I'll just go ahead and share my screen. Can you see my screen?
Yes,
Yes,
I can.
Chandralekha.
Okay, great. All right. So, all set to start. So, hello everyone. Good day. It's wonderful to have you all here. But before starting the session, I'd like to set the 3 ground rules for the session. Please keep your mobile phones away or turn them off to silent mode so that they don't disturb you during the presentation. And please make a note of your queries and shoot them during the Q&A, which is going to be at the end of the session. And we will have intermittent breaks and we can have your thoughts and we can talk about it a bit. And also it's going to be an interactive session as Anirban had informed. I request your attention and active participation, and I assure you this is going to be a very fruitful session. So welcome all. So this is our agenda for today's presentation, and we are going to talk about all these topics in detail. So before I could jump into the presentation, I wanted to ask you all, in the recent years of IT, there has been a rapid increase in acronyms with OPS suffix, OPS. Can you tell me if you had heard any of them? Can somebody unmute themselves and say, or you can even type it in the chat? Yes, DevOps. I get my first answer. GitOps, okay. Maybe from the title of the session. Anything other? Cloud Ops, okay. Yeah. Doc Ops, oh, that's great. Data Ops, ML Ops, yes. Tech Ops, yes. Wonderful. So apart from this, we have AI Ops, HR Ops, Release Ops. So didn't we have development team, security team, or infrastructure team before? Yes, right. We had all these teams, and they did their job perfectly, and we had a lot of robust products delivered. So why is operations exclusively added to all of them now? Is it just a fancy term, or is there any purpose of adding it in the recent years? So let us have a thought on this. So if you feel like it is just a fancy term, no, that's not true, because it is added on a purpose. Operations is added to all the departments because we are evolving in a culture wherein we are heading towards configurable, customizable, and well-defined workflows. We are going to exhibit well-defined contributions by each team and team members, and we are coming with a workflow wherein it can be automatic or manual process integrated together to perform our function efficiently. So there are some automation tools also in our workflow which is going to help us in our day-to-day activities. So to just help with an example, have you heard about the global food brands Lay's, Domino's, Subway? I think everybody would have released their we have burgers and Subways, and so we have released all the tastes. But I wanted to ask you, do you find any difference in the taste? The Lay's chips that you buy here is different, and the Lay's chips that you buy in Delhi is different, or do you find the taste difference anywhere? No, right? So how is this possible? Because they work on the concept of localization of globalization. I repeat, localization of globalization. The process is global, whereas the raw materials, recipes, and the flavors are local. The Lay's chips, if you see, it is not going to be different in Delhi or Hyderabad because they're going to have the process the same and they just play with the flavors and the raw raw materials. So because of its process and the clear defined workflow process, you can guarantee on the quality of the product. Hence, we are aiming to streamline the processes and make it more efficient. So, so this process, should we automate it all the time? No, not necessarily. We should have a definite process for sure, but it can be a mix of both manual and automated process. So now tell me, how to fit in the document, how to fit the documentation in the era of ops. Have you heard about DocOps? DocOps is a very new emerging term, and CA Technologies, now Broadcom, was among the first to publicly use the term DocOps to describe their approach to technical content in 2014. Since then, this approach has been widely adopted and implemented by many IT giants. So, what is this DocOps? So DocOps typically refers to the documentation operations. It is generally used in the context of software development and IT operations to describe the process of creating, managing, and maintaining documentation related to software project or a system. So in this context, all the technical literatures that we prepare, the user manuals, technical guides, system architecture diagrams, and other materials, and the end user need not be a person who is using our service. It can be our internal stakeholders as well, the developers, the administrators. They also use our documentation to understand our product and work with them. So this, if you can see the cycle in the screen, it is more similar to our DDLC, right? So the document development life cycle. That is the beauty of DevOps. It coincides with the operations that we are performing, and this is getting evolved to meet our requirements, and this is going to be very helpful for us in maintaining the quality as well. So in the DDLs, in the DocOps cycle, if you see, first we have our documentation planning, as generally we do. We analyze the target audience, we start our research, come up with a doc plan. So all the planning phase starts, and then we go for content creation, wherein we start defining the versioning system, and we start writing our documents. Like installation guides, user guides, or any developer documentation, and then we update the documents. It can be a new content that is from the scratch, or it can be updates that are happening to an existing document. And then what do? We build our documents in. We give it to a build system, and they generate different formats for publishing it. And then we test our document. We subject them to SME review, peer review, and we test our document internally, and then we publish to a portal, or and sometimes context sensitive helps, where we sell them along with the product. So after this comes the analysis and feedback. The analysis and feedback, so many customers directly interact with the documentation, and there is something called DDF, direct documentation feedback, wherein they just highlight some text and they add in their documentation, and it reaches the customer service team, and in turn it comes to us. So the entire life cycle comes as a part of this DocOps operations, and we can, as I said, effective DocOps practices are crucial for ensuring that software users and developers have access to accurate and helpful documentation, which in turn contributes to the usability, reliability, and maintainability of software systems. So in the essence, DocOps aims to break down the silos between development, operations, and documentation teams. So this leads to more efficient processes, better documentation, and ultimately improved user experiences. It emphasizes the importance of treating documentation as a dynamic and evolving component of an organization's operations rather than a static and isolated task. So this is the starting with defining the workflow. We need to store all the existing documentation in a centralized location accessible to all. So for this, we need a location, and so I want you to just come up with your scenarios. What is your current scenario? Can you all pitch in to share if you have a centralized location where you can store all the documents? Is it centralized or decentralized? Can you unmute yourself, or can you just type in the chat? Do you follow a centralized repository or location where you can store your documents in which you work on? Yeah, I get an answer. OneDrive, Bitbucket, okay, centralized SharePoint, Okay, Perforce, GitLab, wonderful. Okay, Bitbucket, yeah, partly centralized, Confluence. Oh, wonderful. Okay, so what is this? So centralized, some of the widely used centralized repository management system are Perforce, MS SharePoint, SVN, and Google Drive. Yeah, so we have seen a lot of examples in the chat. So a centralized repository stores everything in one place. In a centralized model, you work on code while connected to the server itself. This maintains a single source of truth, but involves a huge investment, high complexity, and ongoing maintenance. There are still many organizations who follow this approach. For example, even now Google follows centralized repository management. So I won't say this is wrong, but I want to come up with some of the limitations, the major limitations for centralized documentation practices. So some of them are the single point of failure. Even we maintain the versioning and updated documentation version, we always have the chance of losing the application. On a centralized version control system, we don't have any online version of the application, so this leads to data loss in a minimum to maximum level. And also there is lack of transparency. Despite the centralized repository system, the policy and governance is managed by a hand-picked resources, and any policy changes can be enforced from time to time. For example, you're using a Google Drive and suddenly Google imposes some policies, and the next day when you get up and you see some policies implemented, and you cannot do anything with that, right? So, and also lack of user operability. Multiple users can work on the same content at the same time. So when the centralized documentation practice is a great challenge. You have to introduce a lock or queue system to effectively manage the user conflicts, which is very challenging. And then they're vulnerable to attacks. You must be very careful with regards to safeguarding your server. If you don't, then all the data will be lost, and you have to go for investing in backup strategies, which are quite expensive. And then you have limited scalability. If you want to scale in future, then it becomes a great challenge. So because of these limitations, we are moving towards a different approach, which is the distributed repository management. A renowned example for distributed repository management system is our Git, Global Information Tracker. It is widely adopted by many organizations because Git is a mature, actively maintained open source revision control system used by thousands of developers around the world. This was created by Linux Torvalds in 2005 to develop the Linux kernel. Even now, it has more than 14,000 plus contributors actively working on. Git is easy to learn and has a very fast performance. It is superior to other SCM tools like Subversion, CBS, Perforce, and ClearCase. And I'll tell you why. But before jumping into Git, I wanted to clarify there is a lot of misconception. Git is the tool, whereas GitLab, Bitbucket, and GitHub are organizations. People always confuse this. For example, I would say copier is a machine, but Xerox and Canon are companies, right? So we always say I'm going to take a Xerox, but it's not Xerox. We're going to take a copy. So before I get into the next segment, I want to take a pause here and ask you. So Puneet, can you please help to post the survey question that we have regarding the level of proficiency in Git? So have you heard of? Okay.
It's already there in the chat.
Okay, great. That's great. Thank you so much. Yes, beginners. Okay, we have. Okay, that's great. I could see a lot of beginners, intermediate, experienced people. Okay, that's great. So now we understood what is Git, a little history about Git. So now let's discuss and explore more about GitOps. So what is GitOps? GitOps is a framework which helps us to do effective collaboration between teams. Developing, testing, documentation, release management teams work hand in hand. In this image, you can see 3 circles that are interconnected, which tells about the GitOps workflow. So GitOps is nothing but it gives you a framework for and tools that can to take the cultural change in coordinating all these teams in a single in a single frame, I should say. So if you see the three circles, Git is the first circle says this Git is the single source of truth. So it is going to give you the framework and the tools, and it treats everything as a code, the second circle. And the third circle, if you see, it is the operations of Git workflows, and you will have a lot of configurable options for you, and you can, and it is not like you're going to code each and everything. No, you are going to just configure the available options to make it useful for yourself, so that the process are all streamlined and very helpful for you. And if you see, all these circles are interconnected, so one after other it just runs in a circle. So if you see the key components of a Git workflow, a Git repository, a continuous delivery pipeline, the CD pipeline that we call, and you have an application deployment tool and a monitoring system. So now let us see GitOps in detail. But before that, I want to add a disclaimer. We are not going to discuss about how to use the command, output of the command. We are not going to troubleshoot the commands. We are just going to talk about the GitHub glossary, the terms that are related to Git. And these are very common terms that are related to Git, but they are very misinterpreted too. So we are here to just discuss and explain the basic concepts and remove a lot of misconceptions. So with regards to Git, the first thing is remote repository. So remote repository, it is the terminologies in Git are very straightforward and self-explanatory. So remote repository means it's a remote location where you have all the source files stored. It is it is a repository where you push and pull, or you do a lot of collaborations and you take a backup. So a lot of operations that you're going to perform, it is on this remote location. And this is called the remote repository. And in the Git language, this remote repository is called the origin, the second bullet. And then how to start working in the flow. So for the first process you do is a Git clone. So Git clone basically makes an identical copy of the latest version of project in a repository and saves it on your computer. It is just like a carbon copy. You copy paste, right? So a Git clone, generally what it does is it takes the latest version of the project, whatever is available in the repository, and saves it in your system. And Git usually works in branches. So if you see, we had a major limitation of centralized repository system where multiple users cannot work in the same time, and they'll have a lot of conflicts. But Git is a boon for these kind of scenarios wherein it works in branches, and each developer work in their own branch without conflicting other developers, other people who are working on Git. So what is this Git branch? Git branch is a parallel version of code that is contained within the repository, and it does not affect the primary or main branch. For example, you have one single branch and you create a parallel version of your code you create, and you work on that. So you play within your branch so that your changes doesn't affect any other people who are working on your repository. So this is a beautiful concept of Git branching. And also it is a pointer to commit. By using branches, several developers are able to work in parallel on the same project seamlessly. So next is your master branch. This is the default name of the first branch. So that is called the master. Since it is a little offensive to use master slave words, now we are moving towards other names such as main or primary branch to say that this is the default or the first formed branch of the repository. Then we are going to talk about the working tree. So the current branch in your workspace is called your working tree. For example, you have a branch, you have your default branch master, and from there you have created your own branch, and this is called your working tree. So when you use a git status command, the output gives you your working tree. So next is a local repository or workspace. So this is another term that is used for your, you have a copy of your remote repository in your workstation, right? So that is called your local repository or workspace. So if you see the flow, what we have done, first we have our remote repository wherein we have all our documents, and that is the origin, and that we are cloning it to our local system. And what do we clone? We clone the master branch, which is the default branch available. And if you want, you can go for other branches if you specify the branch name, but when you just say just git clone, it is going to clone the master branch. And where do you clone it? In your local system, which is your local repository, and there you have your own branch created, which is your working tree. Okay, so now our setup is ready. So now we have all the files, we are going to work on the updates, we are going to create new things. So we do all the changes that we need in the document. Then next step, what we do is we do a commit. So what is this commit? A commit stores the contents of the index in a new commit along with the log message from the user describing the changes. A commit is nothing but a snapshot of the change that you're making. It is going to just store that snapshot with an index in your what do you call, in a memory. Okay, so this commit message is an hexadecimal number, maybe a SHA, and which is not user readable. So what we do, we add a commit message along with this so that we know what are the changes we have made, and we always go and refer to this commit message to know the changes. So now our changes are done and we have taken a snapshot of a change. Next, what we do a git push. So what is this git push? So once the user completes the job, in order to collaborate and publish to remote repository, we do a git push. So you push your changes to your remote. So now all the changes in your local are done and you're fine with it. You're committed the changes so that a snapshot is ready. Then you push to your remote repository, wherein you're ready for collaboration. You're sharing your changes to other people on the repository. But sometimes what happens is, in this process of you cloning the repository, creating your branch, doing your changes, at the same time many users start working in your repository and they create their, so the same process they do on their own, right? So there are a lot of branches created. So there is a difference between the remote and the local. So when you try to push, what does Git gives you is, it says, oh, there are many other changes that are there between, I could identify differences between the remote and local. So what do? So then comes git pull. So what does git pull do? It is a tool that is used to refresh the local working space on par with the remote repository. So there are some branches or new changes that are there on remote. So what should I do? I have to pull those changes in my local so that my local and remote are in sync. Okay, so that there are same kind of files, same kind of changes are available. So then I have a git pull. But in this process, what happens is, if I do a git pull, all my changes will get lost, right? So I have done some changes. So to avoid that, we have a concept called stash. So stash is nothing but another cache memory that acts as a stack where changes can be stored without committing them. So when you do a git stash, what it does, whatever the changes you have done, it is going to temporarily store in a cache. Then you do a git pull, take all the changes from the remote. And then now what happens is, all your changes along with the pulled in information is there in your local. So your local is having both remote changes as well as your recent changes. So now you are very fine with all the changes. Now you have to give it back to your remote repository. So that's when you do a merge. So what does merge do? It joins two or more commit histories. So if it is a GitLab specific term, then we call it as a merge request to let the others know that you have pushed to a branch in a repository. So that is your merge request that you send. And if it is GitHub, you give a pull request wherein you let others know that you have pushed your branch in the repository. So all your changes, whatever is there in the local, then you push it to your remote repository. So that's it. So now if you see, there are many people talking about upstream repositories. So what is this upstream? So we are until now we were talking about remote, local, push and pull requests. So what is this upstream actually? Upstream is nothing but a colloquial term used for a remote repository that you track. So by the word track, I mean when you do a git clone or it is an exact carbon copy of that particular version of the repository, you don't have the tracking. So this is independently working and that is independent. So when you start working on this and when you give up push only, then we try to sync and we get that. Otherwise, these both are independent. But when there is a tracking that is always there, then that you call the upstream repository. The branch on the original repository that has to be forked or cloned, that is called the upstream. So what is forking? So fork is a new repository that shares codes and visibility settings that the original upstream repository. For example, just by the word fork, what we do, so we take something and put somewhere, right? So that is the actual meaning of the English word fork. Similar to that, git clone also takes a copy, git fork also takes a copy, but the visibility settings are also available in this repository along with the code. So that whatever changes you do here, it affects the remote also. So that kind of repository is called the upstream repository, where there is some tracking continuously happening and you have some your changes are also seen. So this is called forking and the upstream repository. So just for an example, I would say, okay, so you have a bicycle and you have a code, just a normal example. So you're going to your remote repository. You have downloaded you have cloned repository which is having a code for running a bicycle. So you're happy with the bicycles. Now what you have done, you have created some special enhancements. For example, you have created a bell, and you have some fancy mirrors attached. So some code enhancements you have done. So now you wish to give back to your remote repository and share your contributions to the repo. So that time, what you give, you push your requests. So now what happens, other people also know about your enhancements. So along with a normal bicycle, your enhancements of bell or mirror is also added. So these kind of repositories are called upstream repositories. And the corresponding branch on the cloned fork branch, so the corresponding to it where you're working, that is called the downstream. So once you work in downstream and you give back, that becomes your upstream. So this is all about the basic glossary terms that we have to know when you're working in GitHubs. But there are lot many, because Git is an ocean. And when you work and practice continuously, you get to know a lot of new other things. And when you face a lot of problems, then you learn more on Git. All right. So now our Git, so now we have done all our changes. Our Git is, repository is ready. Our changes are there on Git. Our code is fine. And then we are moving to a release. So we all work on Jira tickets, right? There is a general saying that developers work in sprints. For example, they're in 100 and 200 meter sprints, but we run marathons, right? So hence the documentation Jira tickets flow through epics. It is not that one ticket you created in one sprint and it's not going to end there. It will be like flowing through epics, because we have continuous updations, and sometimes enhancements happen and they move a ticket to another sprint, and so we juggle between epics. But if you see, our work is all related to branches, release branches, and it's all tied to that. So how will you, so it becomes very challenging to maintain branches across releases. When you have some 4 or 5 releases and you have different branches created, how do we manage them? So to overcome this situation, Git gives us 2 powerful weapons to manage these challenges effectively. Those are Git merge and Git rebase. So these are very powerful tools. So we will see both of them and their key differences. So what is Git merge? As I told you, merge is just going to combine the commit history. So it is going to merge your changes to a remote. So what is this rebase? Rebase is going to change the head of your changes from one branch to another. So if you see in the diagram in the slide, you can see. So the center, if you see, there has a master and a feature branch. The blue color is your master branch, and your pink color is the feature branch. So when you do a Git merge, what happens is, to your master, your features are getting merged. So you see a trunk and 2 different branches. But in Git rebase, if you see, there is a repository and there is a master, and your feature branch turns its direction towards your master and it's rebased in a linear fashion. So this is how the Git function works. So the key differences we are going to analyze in 4 different categories. First one is the commit history. So merging creates new commit that incorporated changes from both the branches, while rebasing applies changes from one branch onto another by rewriting the commit history. If you see, it becomes like, so for every commit, for every merge, a new commit message is added for merging, Git merge. But in rebase, if you see, the entire commit history is rewritten into a single linear fashion. So what happens to your branch structure? The second category that we are going to analyze, merging maintains the branch structure, creates a tree-like structure with multiple branches merging from a single trunk. So it becomes like a fishbone diagram. You have a single trunk and you have different branches emerging from each other. But rebase, what it creates, a linear history with a single branch. So if you see, if you do a Git play and see a branching strategy, it is just a linear fashion with little feature branches coming in and there. So with regards to conflicts, so merging can cause conflicts between changes in 2 branches being merged. For example, I merge one branch and the other person merges another branch, so there become conflicts. It doesn't know which one to take. And rebase also can cause conflicts when Git attempts to replay changes on the current branch. So this is my current branch. When I do a rebase, it will not know how to take in the changes, how to rewrite, what to ignore, what not. So then we do a conflict, we resolve the conflicts by saying, okay, you take my changes, their changes. So conflicts happen in both the strategies, but you will have to know which changes should be incorporated to the master branch. Next use case is when to use these strategies, when to use git merge and when to use rebase. So merging is best suited for integrating changes from long running feature branches. Just as we said, running through epics. There are different tickets which are running through epics and they are long running feature branches. Merging is the best strategy to be followed. But rebasing, it's suited for integrating changes from short-lived branches. So when branches are short-lived and when they have few or no merge conflicts, then you can use rebase. And also when there are multiple contributors working on your long-running branches, merging is best. But rebasing is best suited for short-lived branches with fewer contributors. So both are very powerful tools. Our strategy should be to use a combination of both as per our requirements. So we can never say one is good, other is wrong, but always use a combination. You always merge and work on your local, and then you rebase your changes so that you can give back to your remote repository in a linear fashion so that your changes get in easily. So it's always a combination of both. Right. So I will take a pause here. I know there are a lot of information being shared. So uh, do you have any questions or any thoughts? Anything that you want to know before I jump into the next one? Any questions? I can. Yeah.
This is Ashish.
Yeah. Please, Ashish, go ahead.
Yeah, I just wish to check that let's say we have some delta state in A branch and B branch, and we still have this master branch, and I want to there are some certain new changes in A branch as well as in B branch, and we have to take both of them. Like we have to merge it to the C branch, the master branch.
Okay.
So how do we handle the conflict and how do we handle the overwriting of content?
Okay. So as I said, you overlapping happens in both in merge and rebase. So when you do a merge, what I told you is when you, as you said, there is A branch, B branch, and C branch. For every merging, you create a commit history. So for merge, so there is a master. You merge A, and then you merge B, and you merge C, right? So before merging, when you do a git pull, every time what happens is recent changes come onto your branch.
Right.
So when you're merging B, what you do is you merge A, do a git pull, and then you do your changes, push your B so that there are no conflicts in B.
Okay, got it.
Right. So this kind of the similar fashion you use for all other branches, so there are no conflicts at all.
Okay. Thank you.
Yeah. So you always do a git pull and then only do your merges. That's why I spoke about stash, right? So when you save your changes in stash and then you then do a pull and then finally you do a push, all the recent changes in the branch comes into your branch and then you push your branch so that there are no conflicts.
Yeah, thank you. I understand.
Great. Thank you. And I could see some other questions. Rebase in your, okay. Commit versus push. Explain once more, please. Okay. So commit, actually what does it does is commit is just taking a snapshot of the changes that you're doing in a single point of time. So it's only your index, that hexadecimal value I was talking about, only that snapshot is stored, not your changes. Okay. So when you push, only your actual changes go into your repository. So if you just do a commit and leave off, your changes are not there. So you'll have to commit and then only push. Okay. And then when there are no changes, you will not be able to commit also. You could try this. You go to your repository, don't do any change, try to commit. It will not allow. It will say, oh, there are no changes. Check if you want to commit. Check if there are any changes. So you should have some changes in your document. Then you do a commit wherein a snapshot is taken, and then you push your changes. So that's how it works. Okay. And then clone versus fork, not so clear. Okay. So clone, what happens is, clone is just, as I told you, there is a carbon copy that we are taking in your local system. It doesn't have any linking to your remote and local. There are no links at all. Your remote is different, your local is different. But when you fork, what happens is there is a linking always. You do a fork in your repository, you work in your repository, and always in your remote it says, hey, this person has forked, this changes have happened, this kind of development is going on. But in a clone, you don't have any idea about your clone repository. The parent-child relationship is established in forking, but in clone, both are really independent repositories and they don't have that linking. Am I clear now? You're able to understand? Samyak Mukherjee. So, okay. So if you have any question, please type in again. The next question, upstream repository, visibility settings in fork, its usage. Okay. So the same, as I said, fork is going to have the linking. So you have your visibility settings. For example, I have my master, I have my remote repository A and you have forked B, and always the information about B is visible in A. That is what I call visibility. Okay, so generally what happens is, in open source repositories, there are so many developers working on simultaneously, so they will not have merge rights. So what they do, they take a repository, they take a remote repository, fork it to their local, and their local they clone. So all the changes they do in their clone, and then this forked repository they push to their remote. This is how generally they work, because they will not have merge rights, just to protect their repository. From, say, there are so many contributors, like, so they always restrict the merge rights. So that's why we say fork it has this visibility, but it is more secure, and you will not be able to give the changes back unless they allow. This is how they are protecting it. Please provide a real-time example on Git merge and Git rebase. Yeah, so real-time example, we have so many. We have many, I work simultaneously on different branches for every release. I have some 4 or 5 tickets assigned for a release. And every time what I do, I don't every time clone my repository. I just clone it once. In that, I create different workspaces based on the Jira tickets. And then I do a merge. So every time when I merge to my repo, what it does, it creates a new commit history. So in my local, I do all the merge changes, and then finally I rebase to the actual release branch, so that all my changes goes into a single commit history. So that's how I work in real time in Git merge and Git rebase. That's why I told you we should use it in a combination. Head branch, yeah. So head branch is nothing but branch is the one I told you is a parallel version of the code that you're working on, and the work where you start is called the head. So head is different, branch is different. Both are not same. Okay. Please also speak about cherry picking. This is interesting. Okay, so cherry picking is more of an advanced topic. I thought it will be so confusing if I introduce cherry picking. That's why I didn't include it in my glossary. So sometimes what happens is you'll have to revert your commits based on the release. For example, I work on X release now, and my changes are all there in the repo. Suddenly they say, hey, my release manager comes to me and say, hey, this is not going out for a release. You'll have to revert. So what do? I have to revert that commit, and I have to cherry pick my previous commit and add it to the release. So you will have to find out based on the commit messages, and you have to pick in that particular change and add it to the release branch. So this is called cherry picking. Maybe I can talk about this more during the maybe next time when we meet, or some other session we talk about it, because it's more of advanced and more practical. You'll have to see to know and understand this. Okay, one more. Okay. Is it possible to selectively approve the changes in a merge request? Selectively approve the changes. Actually, yeah. When you do when you're doing a review, automatically your changes you are able to see. So I don't know what you mean by selectively approve. When I complete reviewing the changes made by the writer, pushes one more change, it's getting added to the merge requests. Okay. I get your point. So for every merge request, a lot of commits are added. Yes, you can select individual commits and add and approve them as well. There are how do we do that is individual for every merge you create different commits, and you see that branching strategies in such a way that you merge the changes one by one before committing the change. So in that way you can definitely approve the changes but they should not be tied to a same merge request, because if you take a branch and merge request starts from a branch to the remote one, so your commits are all tied together in the particular branch. So it's always advised that you tie all those commits in a single request and send. Individually, you cannot separate the commits from the merge requests. So that's not possible. Okay, so Samyak. So in a fork, we don't have to do commit, push, pull, as it has already linked to each other. Remote. No. So even in fork, you'll have to do commit, push, and pull. You have to do. There is a linking. I mean to say, the changes are tracked by a remote. In the local repository, whatever changes you made, there is a track. But ultimately, for your changes to get added there, you'll have to follow the same process. You have to commit your changes. You have to push, pull, all this have to be done. Then only your changes will go to your remote. It will just show that it will be your changes. There, it just says, hey, this branch is created for you, and there are work going on. That's all. It will not say what changes are there and what is going to happen. No. So you'll have to do all those changes again.
Chandralekha, we can take up the questions later. We have 5 minutes left.
Sure. Okay. So yeah, next we'll move on to the next slide. I know there are a lot of confusions here, but as I said, you go through the glossaries as I explained. Maybe in the slide also you can just go ahead and read. These are definitions that I wrote on my own based on my practice. So you will understand very clearly, and when you practice it, then you become very proficient. Okay. So the next thing we are jumping on is the key integrations with different delivery channels. So we have our Git repository, code is already there ready. So with this, what do we do next? So we'll have to publish our changes, right? So we'll have to put this somewhere, and our customers have to see through and understand. So what do we do with this key integrations? So once our Git repository is ready, so we can integrate with many other high-level overview of tools and techniques from modern code development workflows, which can be adopted and applied to managing technical documentation. For example, you have the repository and you have multiple tools that are readily available, and this is, you need not configure, you need not write code for any of them. It is all readily available. You will just have, these are just YAML files, and you have to configure them in such a way that they're integrated along with your repository. For example, you have link checkers. These link checkers help to identify the broken links in your document, the images that don't have a description. So these kind of small things it will check and let you know, and it exactly tells you which line of code has this problem so that you can go and rectify them. You can also have a style checker integrated. So style checker, I mean a linting tool that is very helpful to maintain the styles throughout, because many different writers contribute to the documentation. So you'll have to maintain your organization style. So this linting tool, we use Whale. Whale is a linter designed to enforce an existing style guide through its YAML-based extension system. So this extension system has a collection of writing guidelines called styles. So these files are expressed through rules, and you don't have to code anything. You have to just configure, and these rules according to your organization, and they are very much customizable. You can add your own rules according to your organization's need, and you can check for violations in the text in different aspects. It has it has CLI, it has online mode, and it can be integrated with your editors as well as your repository management Git. So how does it work is when you call Whale, it gives you three things. It gives you suggestions, warnings, and errors. So if at all, if any sentence is not proper, it gives you suggestions. It can be written like this. For example, you have certain words, may, could, should. So when you use may, it becomes ambiguous, and the user will not know whether they have to use it or they cannot. So instead, it gives a suggestion saying that please, can you please use some other words like this. So that is a suggestion. And warnings, when they are, for example, you have a short overview written for a feature and it is very small. For example, it is like 250 words you have to use, and you have used more than 250, then it says warning. Hey, you have exceeded the limit. Please check your overview and rewrite. And error, for example, if you use a passive voice and if your sentence is not having fully meaning, and if there it is you have used inappropriate words, as I said, master, slave, blacklist, whitelist, those kind of words which should be avoided, then gives an error wherein you have to change, and then you can proceed with your building. So this is the style checker, and this works with any IDE as well, any plain text editor. So it is very, very helpful for maintaining the styles in the organization. And you also have translators which can be integrated, because your document may not be in English, it can be translated to many different languages according to your customer base. And also you can have the accessibility checker. Your document may not be read by a human, it can be read by bots, it can be read by physically challenged people where they cannot see your images. So accessibility checker will allow you to will screw through your document to see whether you have alt text tabs, alt text written to your image or a table, so that it can read the description of the image if a person is not able to see the workflow diagram or the image that you have added. So these kind of checkings help you to rate your documents on the accessibility level as well. And also there can be a trailing white space highlighter just to avoid spaces, unnecessary spaces that are added, because when you have a PDF version of your document, then each space counts. And then of course you have your building system, which is going to build your document in many different formats that you require. It can be a HTML, PDF, EPUB, or context sensitive help, so whichever format you need. And you of course have a static set generators, which is going to create the required output for you. So all these integration channels can also be integrated with your Git repository. Okay, so by this we are coming on to a logical conclusion of our GitOps, the concepts that we have explained, how to have a refined process, and how to use Git for our own convenience, and how to integrate it with different channels. So what do you think? So with all, are we making the system more complex by introducing all of these? Do you feel it is becoming more complex, more than centralized? Just think. Initially, when the workflows are defined and when you're keeping things in proper place, obviously it may look like it becoming more complex, because a lot of new things you're learning and implementing. But I guarantee you, once the workflow is in place, it is going to be very easy for you. And now we are not getting into a fully automation approach. We are just starting with our manual, and slowly we are integrating automation. And finally, yes, we are going to reach that level where it's going to be fully automated. So fully automation is I should say is a boon, because with a very small team, the continuous CI/CD workflows that have a great advantage in regards to scalability. If the scope of the documentation grows by an order of magnitude, these systems allow small teams to handle it all. So you will be a very small team managing everything, and that is the power of automation. And also the productivity per tech writer grows significantly, and the quality of the documentation as well. So are we breaking the boundaries? Yes, definitely. We are no more silo writers. We don't draw boundaries around us and say, hey, I am a writer, I'm going to do only this. No, we are stepping up, and we are having a lot of other things. We go hand in hand. And you see, when you do a code check-in, we are knowing about it, and the developers know that who is writing that particular feature, and they'll know the contributors and the amount of hard work we do. And all this is easily captured, and you need not speak for yourself. It is all there in the Git and it speaks for you. And is it uplifting the documentation quality? Yes, 100%, no doubt. So because of all these automations, what happens is technical writer can go focus on actual writing, or otherwise improving documentation, creating new helpful content, because we are moving towards different user assets, not only document, but also videos. We have how-tos, tutorials. So a lot of other things are also there for us. We can go find out the assets, learn about it, and get to know and deliver the documents in the required formats. We can also prune the old and outdated information, instead of perpetually battling build issues or taking time out for the day of publish for the prepared documentation. I know. So initially, what happened is, during release, it used to be very stressful. There should be a person sitting there working through all the releases, checking all the formats, and it is very stressful, right? So all these stress situations can be avoided with our CI/CD workflows that we are going to integrate with our repository management Git. So by this, we are coming to our end of a presentation, and these are the additional resources that I have, and these links to, so if you want to explore more about each of them, please jump into and explore more, read about them. And if at all you have anything to know, you have my LinkedIn ID. You can please reach out to me, and I'll be happy to share whatever I know, and we can learn together. So that's all I had for today. And if you have any questions, we are ready to take.
Yeah, thank you so much, Chandralekha. So on the
Thank you,
interest
Anirban.
of time, I hope you have answered almost all the questions. So we'll take two more questions.
Sure.
So
Okay.
one is from Sweta.
Mhm.
How do we include the documentation we create for a specific Jira in this process? She is a
Okay, how
beginner.
do
Sorry about it. Yeah.
Okay. So how do we include the documentation we create for a specific Jira in this process? Okay, so no worries. Jira and Git are interlinked, and you have to just in your Git repository, if you add your particular organization's Jira ID, we say the space Jira space. So whenever you do a push, or when you do a push for a ticket, automatically it is recorded in the Jira ticket. So you need not go exclusively talk about it. When you just push your changes for this ticket, only thing is when you work in your Git repository, you will have to mention the ticket number. For example, we say XYZ ticket. So automatically the same ticket number will be in your Jira, and when you push your changes in Git, it gets recorded in your Jira ticket. So that's how it is. It is like seamlessly integrated, and you do not do anything for this. Okay.
Yeah.
And
I hope that explains your question. You got your answers. Next, another question, or last question of this session. So Sayyad asked, if three different persons are working on the same repository and they see the changes done by the others without committing and pushing the changes?
No. Never they can see the changes, because you're working on individual branches. So the repository is the same, as you said. Branches are the parallel versions that you create. So until you do a commit or a push, other person can never know your changes.
Okay. Thanks.
Yeah.
Yeah.
Thank you so much. So I just want to close with a single word. So yeah, the future of I just want to say you, where are we heading towards? So after all this, so I want to say more of automation. We are heading towards Gen AI, wherein we are talking about automated content. We are talking about chatbots integration and parsing, and this also can be done. And a lot of inventions are going on in this, and I can see many open source projects coming on in this chatbot integration along with documents. Instead of you searching for the document, the chatbots, you just say what you need, and chatbots are going to search the particular content and give it to you, and it's going to parse and give it to you. And also the social media is very powerful these days, and it's not only for content publishing, even for content gathering and curation, we are going to use social media, because customers, more than reporting their problems to your support site, they go and publicize on social media, right? So Microsoft servers down, Google Pay is not working. So you could see these kind of things on the social media spread everywhere. So even tagging these things, that hashtags that you see, even these things can be added to your Git repositories, and these can be tracked, and they can be useful for your content curation as well in the future. So with that, thank you so much for this opportunity, and over to you, Anirban. Thank you so much.
Yeah. Thank you, Chandralekha. Yeah. So guys, if you have any more questions, please reach out directly or join the Telegram group for this one further discussion. So over to you, Puneet.
Thank you so much, Chandralekha. Very nice session, and we can see from the questions. So people are finding it very useful. So, and others, as mentioned, join the groups and please continue the discussions there. And thank you, Anirban, for hosting. So people, we will be moving to the next session of the day, interviewing the doc leader, where we will be interviewing Bhavna. But as mentioned, so we will just give you a 2 minutes break in case anybody needs it. So please be back in 2 minutes and we will start the session.